Unit 7 review. Directions. Simplify using exponent rules. Leave no negative exponents in your answers. Alright, so in this one we know that we've got 5x to the third times 8x squared. We're going to multiply the normal numbers, so 5 times 8 will be 40, and then I'll write down the x, and then we get to add the exponents, so 3 plus 2 is 5, and that is my answer. Number 20. The quantity 5a to the negative 2, b squared, c to the 0, all raised to the third power. I know that if I have parentheses, I'm going to multiply. The first thing I'm going to do is put a 1 on that 5, though. And one thing that I found that if you're struggling, it helps. Go ahead and put everything that's inside of the parentheses down, and now we just need to figure out power. So if I multiply 1 times 3 gives me 3. For the A's, negative 2 times 3 is negative 6. For the B's, 2 times 3 is 6. And for the C's, 0 times 3 is 0. Okay, a couple of things here. First of all, anything to the 0 power is just 1, so we don't even need this part. And then the other thing, 5 to the third power is 125, if you used your calculator to get that. And now we're not allowed to have any negative exponents in our answer, so the A needs to move to the bottom. So we're going to have 125, B to the 6th up top, and we're going to have A to the 6th down below. Okay, 21, continuing to simplify. There's a couple different ways to work this problem. I'm going to work the way that I think is easiest, that we are going to go ahead and subtract because I have a bar, so I'm going to work on the inside first. So I'm going to get x, negative 2 minus 3 is negative 5, and then y, 8 minus negative 4 is 12. And then we have everything raised to the third power, so now we're going to multiply, so we'll get x to the negative 15, y to the 36. We're not allowed to have negative exponents, so we're going to move the x to the bottom, so y to the 36 over x to the 15th. I am going to work this a second way just in case you worked it the other way and got a wrong answer. If you went ahead and multiplied, you're going to get x to the negative 6, y to the 24, x to the 9, y to the negative 12. Now if you subtract, negative 6 minus 9 is negative 15, and 24 minus negative 12 is a positive 36, and we end up at the same spot. Okay, number 22, again, there are different ways to work this one. I'll work it a couple different ways just in case you need to check it your way. First of all, I'm going to put 1s on my x and my y. I'm going to first of all just go right straight across, and if I go right straight across, I'm going to add them. I'm going to get x to the 11, y to the 6th, and then down below I'm going to get x to the 3, y to the 12. Now I know that I need to subtract, so I'm going to get x to the 8, y to the negative 6. We're not allowed to have negatives, so the y needs to move to the bottom, so it'll be x to the 8 over y to the 6. Now if you would have worked it the other way, if we had subtract first, I would have had x to the 3, y to the 2, and then times x to the 5, y to the negative 8. I'm subtracting. Now I get to add the exponents. I'll get x to the 8, y to the negative 6, and notice it puts me in the same spot as before. All right, 23 and 24. Write an exponential function that would possibly fit each graph below. So we know we have to have y equals a times b to the x. That's a must. And a is their starting amount, where it's what's happening at 0, and b is our growth rate. So the first one I notice starting at 1, 2, 3. So this is starting at 0, 3. So we're going to have y equals 3 times, I need it to grow. And if I need it to grow, my growth rate needs to be bigger than 1. So I'm just going to put 2, and it's raised to the x power. This number could be anything bigger than 1. So it could be 1.5, it could be 7, whatever you pick. Okay. All right, the next one, this one, it looks like it's starting at 1, so I'm going to have y equals 1 times, and this time I need my function to decay, so I know that the growth rate needs to be smaller than 1, so I could make it 1/2, I could make it 1/3, I could make it 0.6. I do need the x for the exponent, so this number we just need to have smaller than 1, and I'm just going to put but positive, so we don't want a negative number there. So as long as you checked that, you are good. Okay, 25. We've got some information there, and it says use the data from the table to write an exponential function. Well, we know exponential functions are, again, y equals a times b to the x. The first thing that I would like to check on this one is what is that growth rate? And if you remember what we do on a problem like this, we are going to backwards divide. So I'm going to take 122.52 and divide it by 58.344. And when I do that, I get 2.1 if I rounded it. Okay, and let's backwards divide again. So 58.344 divided by 27.783. And once again, I get 2.1. And let's just keep going, make sure. 27.783 divided by 13.23. Once again, I get 2.1. And then if I do 13.23 divided by 6.3, that also gives me 2.1. So my growth rate is definitely 2.1. Okay, now I need my starting amount, and that my starting amount is what's happening at 0. So we need to put one more number on our table, which is 0. And we're just going to backwards divide one more time. So I'm going to be doing 6.3 divided by 2.1, and that gives me the answer of 3. So my starting amount is 3. So my exponential function is y equals 3 times 2.1 raised to the x power. Okay, part B. Use your equation to predict the y value when x equals 9. So I'm going to have this equation. I'll get 3 times 2.1 to the 9th power. So you're just going to plug that in your calculator. And when I do that, excuse me, I get 2382.84. So about 2,382.84. Okay, number 26. John invested $2,500 into an account that increases at a yearly rate of 12%. Write an exponential function to model the situation. Okay, so again, if it's exponential, we know we have y equals a times b to the x. Okay, our starting amount is just what he invested, so it's just going to be the 2,500. And then times, all right, we've got a percent, and we know if we have percents, we're going to move it to a decimal, so it's going to be 0.12. And this one, we want it to increase. So remember, when we have percents, we're either going to add 1 or subtract it for 1. So since we're going to increase, we're going to add. So we're going to do 1 plus 0.12. This needs to be raised to the x power. So simplifying that just a little bit, our exponential function will be y equals 2,500 times 1.12 raised to the x power. And you can have parentheses or not parentheses. It's up to you. And then for part B, how much money will he have in his account if he leaves it untouched for 40 years? So we'll just be putting 40 in for that x value. So we'll raise it to the 40 power. So let's see what happens when I do that. And I get a big number, 232627.43. So we have dollars here. That means he would end up having $232,627.43. That's pretty good for leaving it there for 40 years. So that's unit 7.